Dear students, I welcome you all for the lecture videos on Signals and DSP, a professional core course 21E63. Today we can discuss problems on system properties. So let us consider the problem. It goes like this. Determine whether the given system is linear, shift invariant or time shift variant, stable, causal and memory. For the given system, y of n is equal to log of x of n. Students, see the problem here. We know the properties of the system. There are 5 different properties. So first one is linearity property, second one is time invariant property, third one is stability, fourth one is causality and fifth one is memory. These are the general properties of the system. Now here the given function is discrete function, that is y of n. Similarly, they will give any continuous function. It has to be represented by y of t. It's a function of whatever the input. Okay. So here y of n is equal to log of x of n. So x of n is the input and it is logarithmic value of the input is given and it is equal to y of n. We know that in general, okay, what is the response? See here, you take any input, that is x of n. If you give to the response of the system, or you can do the transform, okay, or you can call it as a system, okay, then you will get the corresponding output y of n. Okay, so you know this. For any output, it is combination of the input along with the system or response. Now you can see here the function is here log of x of n. Y of n is equal to log of x of n. For this, we have to verify the conditions, above conditions. Now coming to the first one, that is linearity property. Okay, before discussing the condition of linearity property, we know that what is meant by linear system. A system is said to be linear if it obeys the principle of superposition and also it obeys the principle of homogeneity. It means that if any input x of t, then give rise a corresponding output y of t. Otherwise, if it is x1 of t, at the output y1 of t. Similarly, if the second input is x2 of t, it gives rise to the output y of t. So if you add these two inputs, you will get the combination of the output. So therefore, any system you can take how to write the linearity property. So a into y1 of t plus b into y2 of t is getting for an input a into x1 of t plus b into x2 of t. Okay, so this is the input and this is the output. Okay, a into y1 of t plus b into y2 of t is the output. So for the given input, and this is called as the response. This is also called as the transform, okay, or response. The transform of the input will give rise to the output. Okay, now I will take the next step, next line. Okay, so before that, just I will rub this. Now I will take, so if it is y1 of n, y of n is equal to log x, correct? No, so if it is y1 of n, the first input will give rise to corresponding input as log x1 of n, right? Because there are two inputs. Similarly, what is my y2 of n? Y2 of n is equal to log of x2 of n. Okay, you see the linearity principle, okay, and homogeneity. This has to be multiplied with the constants a and b. Now multiply this y1 and y2 by a and b. What will get? Will get a into y1 of n, which is equal to a into log x1 of n. Similarly, b into y2 of n, which is equal to b into log x2 of n. Now we can add these two, you will get, okay, you will get a y1 of n plus b y2 of n will give rise to the system or response as a into log of x1 of n plus b into log of x2 of n. Is it right? That's what I am doing now. Now this is my input, corresponding that I will get the output. Now if I take, already we have taken y1 and y2. Suppose let assume your LHS, let x3 of n. What is my x3 of n? I will take x3 of n as a1 a into x1 of n plus b into x2 of n. Assume this is my x3, okay, a into x1 of n plus, so what is my y3 of n? So y3 of n is equal to log of x3 of n. Output is nothing but what? Function log of x3 of n. So y3 of n is equal to log of, what is my x3 of n? A into x1 of n plus b into x2 of n. Okay, this is my y3 of n. Now you can compare equations with, you can take this equation as 1, take it as equation 2, equation 3, and this as equation 4. Now compare equation 3 and 4. Here x3, here y3. Here you can observe here a1 a into x1 of n plus b into x2 of n, but here, okay, log of a into x1 of n plus b into x2 of n. It means that what? So y3 of n is not equal to a into x1 of n plus b into y2 of n. Then the system is non-linear. The system is non-linear. Over. Now therefore, comparing equation 3 and 4, you come to know y3 of n is not equal to a into y1 of n, not equal to plus b into y2 of n. Therefore, the given system is non-linear in nature. Non-linear in nature. This is the first one, first condition. Okay, if it does not obey the principle of superposition, then it is called as non-linear. Students, in any problem, this is the one property, linearity property, you have to work it out very carefully. Then rest of the properties are very simple as compared to the linearity property. Let us consider the second property, that is causality. C-A-U-S-A-L-I-T-Y, causality. Okay. So what is the given function? Y of n is equal to log of x of n. Okay. So what is the causality principle? The output depends on the present input only. If the output depends on only present input, then it is a causal system. Okay. Now let us see here. Put when n is equal to 0. Now y of 0 is equal to log of x of 0, or put n is equal to 1. Y of 1 is equal to log of x of 1. You can observe here the output depends only on the present input only. Only on the present input only. Then the system is causal system. system. Therefore y of n is equal to log of x of n is a causal system. Okay, so next third one is the time variant property. What is the time variant property? For the given system, if any delay in time, the same delay will be reflected in the input as well as output.
Sorry, sir. Speak.
Okay, so the third property is time variant property. Now let us see what is the given system. Y of n is equal to log x of n. Y of n is equal to log of x of n. Now for this we can check whether the system is time variant or not. Okay, so third one, y of n is equal to log x of n. Okay, we can see if any delay in the time or any advance in the time operation will give rise to the corresponding delay in the input. Now if the input n is delayed by n naught, okay, so y of n minus n naught will give rise to corresponding delay in the input x of n minus n naught. Okay, so what is that? If any input signal is there x of n, okay, you can apply the delay. Then what is my corresponding input? N minus n. This n is called delay. Okay, so similarly, if you apply it to the system, you will get the output, and that output also will have the delay. So when it is follow this condition, therefore y of n minus n naught is equal to log of x of n minus n naught, then the system is time invariant system. Okay, therefore y of n is equal to log of x of n is time invariant system. This is the third one. What about the fourth one? Fourth one is stability, and the fourth one is stability. So how to define stability? Can you tell me? Can you recall the basic principle? Okay, if the given input is bounded, if the input is bounded, then the corresponding output also, then the corresponding output is also bounded. It means that for bounded input you will get the bounded output. So that time, so your magnitude of x of t is always less than or equal to any integer value, positive integer value, which is less than infinity. Okay, so therefore the system is stable system. If the input is bounded, automatically it will be the bounded output. So bounded input means what? The value of the integer is always a finite positive value. Therefore you will get the finite positive output only, which is less than infinity. Therefore you will get the bounded output. The last one is causality or memoryless. Last one is memoryless. What is the condition for the memoryless? The output depends only on the present input, then it is memory. If the output y of t depends only on x of t is memoryless. If it is depends any past input values, so you required any memory, therefore it is called as memory. So here we can check, okay, the given input y of n is equal to log of x of n. Y of n is equal to log of x of n. See here, the output depends only on the present value of the input, therefore the given system is memory. If the input depends like x of n minus 1 plus log of x of n minus 2, you can see here the output depends also the past input value, then that time the system is a memory system. Here the only function is log x of n, therefore the output depends only on the present input, then it is a memoryless system. Therefore y of n is equal to log of x of n is a memoryless system. We can recall all the 5 now. So you can now it is a memoryless, and the bounded input is a bounded output, therefore it's a stable system. Next, if there is any delay in the input, there is also a delay in the output, therefore if the given system is time invariant, and it is a causal system because the output depends only on the present input, so it's a causal system, and it does not obey the principle of superposition and homogeneity, therefore the given system is a non-linear system. I hope you'll understand. Okay, these kind of problems are very important in exam. Okay, thank you. With this I'll complete my session. Thank you.